All right, welcome back, RF technicians. In this part of our deep dive into radio jamming, we're zoning in on something you'll definitely see out in the field, the jamming of key fobs and other remote controls.
Now, before we get into the weeds, we have to put this up front. This is part 3 of a big 20-part tutorial, and it's all based on an incredible report from RFI detectives. We're providing this strictly for educational purposes, specifically for interference mitigation. I have to be really clear here. Using radio jamming equipment is illegal in most places, and the penalties are no joke. This whole series is to help you, the technician, learn how to identify, locate, and report these signals, not to create them.
So let's set a scene you probably know all too well. You get the call, a client's key fob for their car, their garage, their gate. It's just dead. The first thought is always the battery, right? But what if they tell you they've already changed it and it's still not working? Well, that's when your job gets interesting, because the real culprit might be something a lot more intentional. Key fob jamming, it's a really unique kind of problem. It seems simple, maybe even like a minor annoyance, but it's a surprisingly effective and damaging threat. It can mess with everything from daily convenience to actual security. So let's really break down what we're up against. So what exactly is key fob jamming? Well, technically, it's a kind of RF interference that takes advantage of the very thing that makes these remotes work. Think about it. They're designed to be low power and only work over a short distance. This is great for saving battery life and not messing with your neighbor's garage door. But as we're about to see, that specific design choice, well, it opens up a huge vulnerability. So what is this big vulnerability I'm talking about? It's all about the receiver. Yep, the very piece of engineering that makes the whole system work is also its Achilles heel when a jammer enters the picture. And here is the core of the problem. It's a trade-off. See, on the one hand, a car's receiver is built to be incredibly sensitive. It has to be, right? It needs to pick up that tiny, weak signal from your key fob from way across a parking lot. But on the other hand, that high sensitivity is exactly what the jammer exploits. It doesn't need a ton of power. It can just pump out some low-level noise on that same frequency, and poof, it completely overwhelms the receiver. The receiver just can't hear that little key fob signal over all the shouting. And all these insights, by the way, they come directly from the experts over at RFI Detectives. Their field report is what this entire tutorial is built on. Okay, let's get to the part that really matters for your work in the field. The theory's important, but knowing exactly which frequencies to watch is what solves the case. So think of this next part as your essential checklist. This table is your new best friend. Seriously, as you can see, the frequency you're looking for totally depends on where you are. Here in North America, you're going to be parked on 315 megahertz. In Europe, it's mostly 433.92, but you'll also see 868 for other short-range devices. Asia has its own thing going on, and don't forget the curveballs. Some of those fancier premium systems might use 915 megahertz or even get into ultra-wide band. Knowing your local frequency, that's where everything starts. Let's just hammer this home. If you are a tech in North America and you get a call, especially about multiple key fobs failing in one area, this is your number. Your spectrum analyzer should go straight to 315 megahertz, no questions asked. That's your prime suspect. You're looking for an unusually high noise floor or maybe a steady signal that just won't go away? All right, let's bring it all together and boil it down to the key things you need to have in your head when you're out on a call and you start sniffing around for this kind of interference. Okay, first, remember the why. It's all because the receiver is so darn sensitive. Second, because of that, you don't need a huge, powerful jammer to cause chaos. Even a small, low-power one can do the trick. Third, and this is the most critical part, know your local numbers. 315 in North America, 433 in Europe. That's where you start looking. And finally, if those common frequencies look clean, don't just pack up. Remember to check the premium system frequencies, like 915 megahertz. So you've done it. You found the interference, it's on the right frequency, and you're pretty sure a jammer is active. Awesome. But now for the million-dollar question. Where is it coming from? Knowing what is happening is only half the battle. Pinpointing the actual source, well, that's a whole other skill set, and it's exactly what we're going to tackle in the next part of this series.